So welcome back to the new episode. We are going now to look at simultaneous equations. So simultaneous equations are not new. Like what you learned at O level, the same methods which you use at O level, they are the same methods which you are going to use when we are calculating or solving the unknowns when it comes to this advanced level. We are not changing anything, but we are only now advancing, adding on. Like at O level, you use only to deal with two linear equations, two unknowns, but this time around here we can now adjust to three unknowns. How do we handle such a kind of that? First of all, you should know what a simultaneous equation. A set of equations which contains three or more, or the number of unknowns exceeding or equal to the number of unknown variables is what we call a simultaneous equation. We can say a set of equations which with more, let's can say a set of equations with more or equal number of unknown variables is termed as simultaneous equations. Is termed as simultaneous equations. So we may find that an equation has got the number of unknowns which are tallying with what is required, or the exceeding what the unknown in equations are. So those ones we call them, these are simultaneous equations. In brief, we mean simultaneous equations are equations which have got two or more unknowns and which needs to be solved or to be found. Those ones we term them to be what we call simultaneous equations. So for our case, we are going to look at the three linear equations. Three linear equations. So examples of linear equations, examples of three linear simultaneous equations. Linear simultaneous equations are, or is, you can say the first one can have a1x plus b1y plus c1z equals d1. Then another one can have a2x plus b2y plus c2z equals d2. So another one can have a2x plus b3y plus 3z equals d3. So you can see that this one is the first equation, this one is the second, this one is the third. So here it means that x has got the coefficient of a1 for the first equation, and y1 has a coefficient of b1, and z has a coefficient of c1, and d1 being the constant. So this is the first equation. You can see it has got three unknowns which needs to be solved. Like we need to get x, we need to get y, we need to get z for all the equations, such that when you substitute in, it can easily bring what the exact value is. And there, can we say, there are several methods. There are several methods of solving these linear simultaneous equations. These linear simultaneous equations. Why am I including the word linear? Linear comes from the word line, because there is nothing like we are dealing with x squared. So these include one, we are going to have what we call elimination stroke substitution method. So for them they work hand in hand. So number 2, we shall use what we call Cramer's and echelon. Cramer's and echelon form. So we are going to choose a elimination stroke a substitution method, and it will also go to Cramer's and echelon form. So what is common here, we normally use what we call elimination and echelon form. A question will come and say, use echelon form reduction to matrix form to solve the following simultaneous equations. Or the question may come and say, use the elimination to solve the simultaneous equations. Or a question may just come open and say, solve the simultaneous equations. Now when they say solve the simultaneous equations, it's upon you to choose which method are you conversant with. They have not restricted. But if they say use the elimination, strictly use what we call elimination method, because it will be very, very important for you to use that elimination method, as we are going to be seeing in our first example. So we are going to start with the elimination method. Elimination method. So when we talk about elimination method, this involves eliminating, or we use what we call, this involves adding the multiples of a number and again subtracting them from one equation to the other. So it's not about adding the multiples of the variables in the both equations and you see which one is common, then you apply the idea of substitution. So I'm going to start with example. We are going to start with elimination method. Elimination method. So here we shall not even take much of the writing. I've said when we talk about elimination method, it's all about adding the factors of one value of variables so that you can easily be eliminated. So you see which one is common and such that you can easily eliminate it. So example 1, I'm going to use example 1 and we say use elimination method. Use elimination method. Use elimination method to solve the simultaneous equations. Solve the simultaneous equations. Solve the simultaneous equations. And our first equation goes as 3x plus 2y minus z equals 9 is 3x plus 2y minus z equals 9. You can see this equation is having x, y, and z, which is in the same form which I gave you. Then the second one goes 2x minus a y, 2x minus y minus 2z. You can still see it as having those variables equals a 4. Then another one is x plus y, x plus y plus z equals 1. You can see there are 3 equations, and all of them being 3, they are also having 3 unknowns. At O level, you used to deal with 2 equations having 2 unknowns. You can see here. So this seems so. And when you go to the university, first year, you are going to find these ones there, and it will be very easy for you to do them. And in any case, no any exam of these days misses. So what can we do? Now what you do, look at the numbers which have got what we call a common factor, which can easily be eliminated. First, see, this is my first equation, this is the second, this is the third. What relationship is there? I can see with the equation 2 and this one, there is y and negative y and y. Again with 1 and 3, you can see there is negative z and positive z. So it is easy for me to either add of any of those ones. I can either add 1 with 3, or I can add 2 and 3. So which one is easy for you? I can say equation 2 plus 3. Let me add them so that I eliminate y. So when we add 2x plus x, we are getting 3x. Negative y plus y, it goes. Negative 2z plus a z, you get minus z equals 4 plus 5 plus 1, you are coming out with 5. I can call this one equation 4. You can see I have now remained with x and z. So I can also now deal with another equation and eliminate. I can also deal with number 1 and 2. I can deal with 1 and 2. And for this case, which ones should I eliminate? I can also eliminate y, so that I remain with the equation dealing with x and z. So, and what can I do with this? I can eliminate y by using the usual method. I can say solving 1 and 2. 1 and 2 can say equation only having 3x plus 2y minus z equals 9. Then another one is 2x minus y minus 2z equals 4. Can I eliminate y? Up I'm going to put a negative 1, then down I put a 2. So can we get negative 1 times this, I get negative 3x. This times this I get minus 2y. This times this I get plus z equals negative 9. 2 times this I'm getting a 4x, then minus 2y, then minus 4z equals 8. What can I do in order to eliminate this y? What can I do to eliminate y? Subtraction. Can we deduct negative 3x minus 4x? We are getting negative 7x. Negative 2y minus 2y, then y disappears. Z minus 4z, we are getting plus 5z equals negative 9 minus 8, we are getting minus 17. This is equation 5. So you can see this one is in terms of x and z, and also this one is in terms of x and z. So we are going to say solving 4 and 5. We are now handling 4 and 5. We want to deal with those categories where we have x and z. So what was equation 4 saying? Equation 4 was saying 3x minus z equals 5. Then equation next was saying negative 7x plus 5z equals negative 17. So I can start from 1 and I make maybe z from 4. I can say from 4, or you can even eliminate here. You can use a method. You can use substitution now for me. From 4, make z the subject. Z becomes 3x minus 5. Substitute it in the equation 5. You can say put, I can maybe call this one star. Put equation star in 5. What was equation 5 saying? Negative 7x plus 5 into you bring 3x minus 5 equals negative 17. So we are free to open now. You can see it is now in terms of x. So we can open, we say this becomes negative 7x plus 15x minus 25 equals negative 17. So negative 5x plus 15x automatically come out with 80x equals, we take the other side, it becomes negative 17 plus 25. So I've got 8x equals 8. So x is 1. After getting x is 1, then you are free to substitute in and come out with the value of z. You can say in star z equals 3x minus 5. So z equals 3 into 1 minus 5. So z automatically becomes negative 2. After coming out with z equals negative 2, then you are supposed to substitute in any equation of your choice to get the value of y. So I can substitute in n, I can use equation 3, because equation 6 would not say that we have undermined it. All of them, they're important. And after getting all your variables, you are supposed to substitute in n to test if they are bringing what is in the right hand side. Then from there, you'll even sleep. Even when you are busy there coming out of an exam, you will simply know that you have already got. So you can say in 3, we had x plus y plus z equals 1. But we know the value of x. X is already 1 plus y, which we want, plus z, do we know it?